Alright, in this video we will explore some basic set theory, and we're going to start with some Venn diagrams. So if this is set A and this is set B, we can talk about the intersection of these. And the intersection is given by these symbols, A intersection B. Or sometimes they will use words and say A and B. Either way, it means the overlap between these two sets. So the intersection of A and B would be this part that I just colored in yellow. Now, on the other hand, let's look at another situation. So here is set A. Whoa, that ink is really dark. And here is set B. Gotta tone that down. We could talk about the union of these two sets. Union. And the symbol for that would be A union B. Or sometimes they use words and they'll say A or B. Now, when you do the union, you take everything in set A and everything in set B and you just put it all together. So if I were going to color that for you, the union of A and B, okay, would be all of this. Alright, if I just color it all in, that's the union, A or B. Now really, I should be putting a box or something around each one of these to represent the universe. Okay? Alright, that border represents the universe. So if there's anything that's not in A and that's not in B, it would be outside of the circles, but still in the rectangle. Okay, now let's talk about something called the complement. Alright, let's say that this is set A. Alright, there's something called the complement. And it is given by the following symbols. We'll say A, and then we'll put this little prime on it. And this would be read not A. Because the complement means everything in the universe that is not within set A. So if I were going to color this, I would be coloring everything out here. Alright, because it's everything in the universe that is not in set A. Okay, so that's not a flawless coloring job, but you get the idea. That would be a picture of the complement of A, not A. So problem number 1, this is the intersection of A and B. That means we want to shade everything that is in A and in B. So if I were to shade that mess, it would look like this. Okay, so this is everything that is in A and in B. Okay, so this will put my coloring skills to the test. All right, looking at problem number 2. This is the intersection of A and the complement of B. When we see this complement of B, sometimes we say not B. So we want everything that is in A and not in B. All right, we want everything that's in A and not in B. So look, here's everything that's in A right here. Okay, all of this is everything that's in A. But we want the part of this that is not in B. Okay, so how much of this is not in B? Well, the part that's not in B is the part that stays out here. Okay, so the solution is going to be this part out here. So here's a picture of everything that is in A and not in B. So looking at problem number 3. This is simply the complement of A. So that means we want everything that is not in A. That's what this means. So that means we're just going to be simply shading in everything that's outside of A. So here I've shaded in everything that is not in A. Okay, how about problem number 4? So this is the union of B or C. So we want to shade in everything that is in B or in C. So we're not looking for the overlapping part, we want it all. So we're going to wind up shading in everything that is in B, which is going to be like this. But we will also shade in everything that is in C. It's all included when you're doing the union. You keep everything that's in either group, either set. Okay, so not a perfect coloring job. I'm out of practice with my coloring, but that's a pretty good image. Okay, for number 5, we have a triple intersection. We want the intersection of A and B and C. So we have to shade in everything that is in A and B and C. It's got to be in all 3 places at once. Okay, so we really are looking for the overlapping area of all 3, which is right in here. All right, hopefully you can see that this is the space that represents everything that is, everything that I just shaded is inside of B, and this shaded area is also inside of C, and it's also inside of A. It's in all 3 at once. Okay, take a look at problem number 6. We want the intersection of A and the complement of B. That means we want everything that is in A and at the same time not in B. Okay, what is in A but not in B? Well, let's start with what's in A. So here is a shading of everything that is in A. It's like this. Okay, now, but what part of this is not in B? Okay, so you can probably see that this portion right here is in B. So we need to throw out that part. So we just want we really just want to shade in the part of A that is not in B. So it's just going to be this part out here. So here I've shaded in the part of A that is not in B. All right, well, something is wrong with this Venn diagram right here. So let's see what the scenario is and see if we can fix it. Miss Kennedy asked 32 students about movies they've seen. 20 students have seen Star Wars, 8 students have seen Despicable Me, and 3 students have seen both. So we're going to let S represent the set of students that have seen Star Wars, and so that's represented by this circle on the left. And we'll let D represent the set of students who have seen Despicable Me. So that's the circle on the right. So can you tell what is wrong with this diagram? So how many students have seen Star Wars? 20. But look, this is the Star Wars circle right here. So according to this diagram, 23 students have seen Star Wars, instead of the 20 students that we were told have seen Star Wars. So they're double counting the 3 students that have seen both movies. So they're coming up with 23 students seeing Star Wars. That's too many. So in the same way, if you look at the circle that represents a set of students who have seen Despicable Me, all right, fine. 3 students have seen both movies, but if we just ask ourselves how many students have seen Despicable Me, that's going to include the 3 students that have seen Star Wars as well. So according to this diagram, that's 11 students. But really, it's supposed to be only 8 students that have seen Despicable Me. Okay, so that's what's wrong with this diagram. They are treating the overlapping number of students that have seen both movies as being a separate set. But really, these two numbers together have to add up to the total number of students who have seen Star Wars. And these two numbers together have to add up to the total number of students who have seen Despicable Me. So let's fix the diagram. Okay, so fine, we know that 3 students have seen both. So putting the 3 in here, that part was correct. Okay, now, if there are 20 students that have seen Star Wars, we've already accounted for 3 of them right here. So how many does that leave for this part of the diagram? This must be 17, all right? So 20 students total have seen Star Wars. 3 of them also saw Despicable Me. 17 of them only saw Star Wars, but total of 20. Similarly, for Despicable Me, 8 students have seen Despicable Me. 3 of them have already been accounted for right here. So that leaves 5 students in this part of the diagram who have only seen Despicable Me. But if I were to ever go back and shade in the Despicable Me circle, I would see, yep, that's 8 students total. Okay, now we have 20 students so far, all right, who the 17 students who saw Star Wars only, and then 3 students who saw both, that's 20, plus 5 more is 25. The total number of students that Miss Kennedy asked was 32. Okay, so that leaves 7 students who didn't see either Star Wars or Despicable Me. So in the original wrong diagram, we had 1 student here who hadn't seen either movie. But now we see that really it's 7 for a total of 32. All right, so now we're going to answer a few questions based on the diagram. Of course, we'll be referring back to the correct diagram as we answer these questions. So for problem number 9, set S, what does that represent? Set S is the set of students who have seen Star Wars. So let's see, students who have seen Star Wars. So we'll put a B right here because that's the correct description. So what's the size of that group? So the number of students who have seen Star Wars, that's 20. All right, the 17 and the 3, total of 20. Okay, now this is the complement of S, which means not S. Okay, so this represents students who have not seen Star Wars. So let's see. You know what? I should cross this out because we already did that one. All right, students who haven't seen Star Wars. That's going to be D. All right, students who haven't seen Star Wars. Okay, so that's going to be the 5 and the 7. All right, those are the students who have not seen Star Wars. So that's going to be 12. We also could have just done 32, the total number of students, minus 20. But anyway, that's going to be 12. Okay, then problem number 11, the intersection of S and D. So that should be students who have seen Star Wars and Despicable Me. So of course that's the 3 in the middle of our diagram. Okay, students who have seen both movies, so that's A. Okay, now the intersection of S and the complement of D. So this will be students who have seen Star Wars and have not seen Despicable Me. They've seen Star Wars and not Despicable Me. Okay, let's see. All right, so that is description C. Okay, so there are 20 students who have seen Star Wars. 3 of those have seen Despicable Me. 17 have not seen Despicable Me. So that's going to be the 17 students who have seen Star Wars but not Despicable Me. Okay, now we have the complement of the union of S and D. All right, so the complement means not in S or D. So look, just if I do a little quick highlighting here, this is the union of S or D. All right, so that's all the students who have seen like either movie. All right, so the complement of that will be students that I did not highlight just now. So the students who have not seen either movie. Okay, so of course that is description E, the only one that's left, students who haven't seen either movie. And that is the 7. Okay, for the next couple of questions, students recorded whether they fell into each of these categories. Category J, they're wearing jeans today. Category B, they have blonde hair. And category G, they are wearing glasses today. So we got the Venn diagram over here. So for number 14, is Carla in the set J complement intersection G? Well, J complement means she's not in set G, and she is in, I think I said G. J complement means she's not in set J, and she's in set G. So let's start with the not J part. Okay, is that even true? Well, here's Carla right here. And you can see that Carla is, in fact, inside of circle J. So, so this is not true. All right, Carla is not in the set not J, because that would mean that she's not inside circle J, and she actually is inside circle J. Okay, so I went ahead and wrote that up in a quick sentence. J complement means not in set J, but Carla is in set J. So she is not in the set J complement intersection G. Now, is Jenny in the set the complement of the intersection of J and G? Well, let's see. This means not in the intersection of J and G. Okay, so let's find the intersection of J and G and see if Jenny is in there. Okay, so let's see. Here is the intersection of J and G, right here. This is where those two sets overlap. Is Jenny in there? And yes, she is. She is in there. All right, but this set for problem number 15 is the complement of that. So that means she's not in J and G. So this is false, all right, just like number 14 was false. So is Jenny in this set? No, because, and here I'll just write a quick sentence. So Jenny is not in the set because this would mean that she is not in the intersection of J and G, but actually she is in the intersection of J and G. So that means she's not in this complement. Okay, number 16, is Rose in the set G union J intersection B? Okay, well, let's start with J intersection B. So that's going to be the overlap between J and B. Okay, so here comes the overlap between J and B. This is the intersection of J and B. So there's the intersection of J and B. Now, we want the union of this and set G. So when you're doing a union, you want everything. So we want everything we just highlighted, and we want all of set G. So here comes set G, which is all of this. And so when you're doing the union, you just keep it all. So this would be the union of the intersection that we did first, and then all of set G. So now the question is Rose in this set? So here's Rose right here, and Rose is clearly in the set. So as far as explaining, we can say, yes, Rose is in this set because this is the set of people who are in G or J and B. And since Rose is in J and B, you know, she's in the intersection here, then she is in this set. Now, last question. Is Bob in the set B intersection G intersection J complement. So this is going to be the set of people who are in B and G but not in J, right? J complement means not J. So we're looking for, we're going to shade the region that is in B and G but not J. That's what we're about to shade. B and G but not J. Okay, so here is the overlap between B and G right here. Okay, so if we just wanted the set of people that were in B and G, then this would be it. But we want the set of people who are in B and G but not J. So that means we need to get rid of this part of the graph right here, alright, because that part is in J. So we want B and G but not J. So we just have to redo this a little bit to get rid of that portion of the graph. So that's going to leave us with this. Alright, so here we have B and G but not J. And there's Bob, is the only one in that region. So is Bob in this set? Yes. I'll just write a little sentence to explain. So we can simply say yes because Bob is in B and G but not in J. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.